In this video, we are going to solve a very simple problem based on the reactions of phosphorus compound. The reaction of PCl3 with methanol in the presence of triethylamine affords compound X. They are given some hints also about X. EI mass spectrum of X shows a parent ion peak at M by Z value 124. Microanalysis of X shows that it contains carbon, hydrogen, oxygen and phosphorus. The H1 NMR spectrum of X shows a doublet at 4 ppm. The separation between the two lines of the doublet is approximately 15 Hz, that is J value, coupling constant. Compound X is. You should know the answer even without these many hints. If you are good in organic chemistry, you can solve this problem in no time. This is PCl3. There will be lone pair of electron also. So the geometry of PCl3 will be tetrahedral. To this, methanol is added. Methanol has lone pair of electron, that is nucleophile. 3 Cl atoms are attached to phosphorus, so there is some electron deficiency on this. Methanol can attack this. Cl can be removed. What we get is trimethyl phosphite. All 3 Cl will be replaced by methanol. It is simply nucleophilic substitution. But generally, this kind of mechanism you can't find in any book. In general, for inorganic reactions, we don't discuss reaction mechanism like organic chemistry. Cl minus combines with this H, HCl is formed in this reaction. To remove this HCl, we require triethylamine. Triethylamine will react with HCl. As base reaction will take place, a salt will be formed. So basically, triethylamine is acid scavenger. So the product, whatever we get in this reaction, is trimethyl phosphite. Now let us go to the clues or hints, whatever they are given. EI mass spectrum of X shows a parent ion peak at M by Z value 124. Phosphorus 31, oxygen 16, methyl 15. So that also will be 31. So totally there will be 431 if you add 124. The mass of trimethyl phosphite is 124. Microanalysis of X shows that it contains CHO and phosphorus. Here you can find CH3, oxygen and phosphorus. All the 4 atoms are present. The H1 NMR spectrum of X shows a doublet at 4 ppm. Here Me is attached with oxygen. So the chemical shift value will be between 3 to 4. We can expect around 3 to 4. Here it appears around 4. All the 3 methyl groups are in the same environment. So we will get only one signal. What about multiplicity? The signal will be splitted by phosphorus atom. Phosphorus atom has I value of half. That spin value can split methyl signal. Because of that, we will get doublet. And the coupling constant will be around 15 Hz. This is another problem based on the same question. Upon heating, compound X is converted to Y. This is compound X. Trimethyl phosphite is compound X. Upon heating, it is converted into Y, which has the same molecular formula as that of X. To predict Y, they are given some hints. The H1 NMR spectrum of X shows 2 doublets centered at 3 ppm. The coupling constant will be 20 Hz and 4 ppm with coupling constant 15 Hz. They have given NMR spectrum as well as they have given the molecular formula. Simply, they are heating. So in the CHN analysis, there will be carbon, hydrogen, oxygen and phosphorus. In fact, oxygen cannot be identified in CHN analysis, but the atoms present in compound X and Y will be carbon, hydrogen, oxygen and phosphorus. Let us go to the given options. The second option is trimethyl phosphate itself. So this is not possible because X is trimethyl phosphate. Y cannot be trimethyl phosphate. Let us go to option A. Here I have only one CH3. And if I go for the molecular formula, it will not be 124. The molecular formula of this is something different from trimethyl phosphate. So I can eliminate this option also. For the same reason, I can eliminate this option also. The molecular formula will not match trimethyl phosphate. So only this option is right. Let us go for the reaction that takes place upon heating. This is trimethyl phosphate. The geometry is tetrahedral. Upon heating, this bond falls here. This will become Me plus. That Me plus will be added to phosphorus. What we get is P. Here methyl. We will get double bond O here. OMe and OMe. What we get is phosphonate. Now you can compare the molecular formula. The molecular formula will be same as this. Basically this is some kind of rearrangement. You should be very familiar with this kind of rearrangement. Let us consider H3PO3, phosphoric acid. Phosphoric acid generally exists like this. H3PO3 generally exists like this. This bond will fall here. H plus will be taken by this. We get this. Same way here, instead of H I have methyl.